All right. Let me get everything ready.
Hey,
Hello. Not everyone's here yet. I'll wait a couple minutes.
if everyone's happy with it, is it okay if we start the marble presentation from the beginning? I know we did the first 10 minutes or something, but
Yeah, well, I was planning on doing it from the beginning anyway.
okay, cool.
It's more complete this time around, and we also have the practice exam in there. I see a lot of double names, but that's probably because people use the same link, right? If you can in the participant screen. You should probably change your name if you have the wrong name. Not that it matters a lot, I guess. All right, well, I think I'm gonna start with the introduction at least. And I should open the chat. All right, welcome everyone to the second and final session for this crash course. Last time we did mostly prologue, a little bit of theory, a little bit of Marble. Today we'll spend around 2 hours on Marble, trying to go for the entire practice exam, and 1 hour on recursion. Since recursion requires a lot of practice, that's basically our planning for today. I did notice though that doing the entire but Marble is quite on a high level, and it is quite difficult to get on a high enough level in one day. So the last couple of questions I noticed in the previous session are really quite a bit more difficult. Same goes with recursion. At the end of today, we'll be able to do the basic recursion, but to get on a level as high as the exam, you guys will need to also practice on your own, because you simply cannot learn it in one day. How many participants are here? There's 11, not me included. I think it's time to start. Right, let's start with Marble. Half of the exam, of course. First, let's set up an example that we will be using during the lesson. So we'll consider the following scenario: the vacuum cleaner bot. You will probably have seen the vacuum cleaner bot in intelligent systems already, and maybe also in multi-G systems. But we will change it up a bit. This vacuum cleaner bot will be in real life. So we consider a vacuum cleaner bot that has to clean a real life house. We consider anything we can program an agent. And yeah, especially the environment is going to be a simple family house that is equipped with cameras in every room. So there are cameras outside of the bot. And let's just quickly go over the properties of an environment just to make sure that just to have had some practice with it. So this environment, is it deterministic or stochastic? Is it discrete or continuous? I hope you guys still know what these terms mean. And if you have any answers, please send them in the chat, preferably with a little bit of an explanation.
Can you go back to the environment conditions?
Sorry?
Can you go back a slide just so we can see?
Yep. So we're asking about deterministic or stochastic, and discrete or continuous. Did everyone catch the question? See, I can't tell if people are typing or not. The question was, is this environment deterministic or stochastic, and is it discrete or continuous? Is everyone there? Stochastic, since there is randomness in real life. Yep, that makes sense. What about discrete or continuous? Discrete in one room. Sorry, I just don't remember. All right, that's fine. If you guys don't remember, you can always ask. So deterministic or stochastic means, is there an element of randomness? And deterministic means that if you know the action of the agent, you can always determine what the state of the environment will be. Since in real life, it's going to be deterministic because obviously I mean stochastic. Since real life is too hard to, real life always has an element of randomness, like random wind or random humans doing random things. Is it discrete or continuous? In this case, I would argue that it is continuous because discrete or continuous means, is there a finite amount of states? And I would say it's continuous, which means that there is an infinite amount of states because there are an infinite amount of places, thus can be infinite amount of dust that can accumulate in one place.
But it's in what it's in one room, right? Or in one house. So, and it's real life, it's not like infinite numbers. So it is countable in the sense. And I thought that something is discrete if it's countable, even if it's an extremely large number, and continuous if it's like uncountable, like imaginary numbers.
No, so discrete would be like if you had so imaginary numbers is not really, it's a bit going too far for continuous. A better way to see it is, for example, say you have a room that is 3 meters wide. You can have a can have dust sitting at 1 meter, at 1.1 meter, at 1.11 meter, at 1.111 meter, and you can go on forever like that.
Yeah. Okay. Okay.
That's the way they used continuous in well, in intelligent systems and in multi-agent systems.
Okay.
While discrete would be, it can be 1 meters, 2 meters, or 3 meters, and nothing in between. Okay, next, so multi-agent or single agent. I think this one speaks for itself. Fully or partially observable, so how much can the agent see everything? And static or dynamic, which means, does the environment change if the agent doesn't do anything? So yeah, answers in the chat. All right, I already see a answer in the chat. Anyone else? All right, so the consensus seems to be a single agent. That is true because we define an agent as something we can program. So these humans are not part of the agents; they're part of the environment. Fully or partially observable. Yeah, so there's supposed to be like cameras everywhere, so we're gonna say that it's fully observable because there isn't a part of the house that's not covered by cameras. Static or dynamic. Dynamic because if the agent is just standing still, there are still humans that are parts of the environment that can move things around or place new dusts. Any questions about this? These are, by the way, not. This is just an example that I made up. It's more meant to think about, and if you encounter this on the exam, they will be more specific in what the conditions are. Weren't there more agents? No, so the environment is just one vacuum bot, and anything that we cannot program is not part of the agents, and we can only program the vacuum bot. Right, now that we had that, refresher, or maybe something entirely new. I don't know if the professors ever mentioned this, but what are the free abilities of an agent? Does anyone notice this? Was this mentioned during class at all? My best guess was that it was maybe mentioned once, but that it wasn't regarded as important enough to remember or to repeat. So I'm going to assume it wasn't, nobody really knows the answer. It's probably not very important, but it's nice detail to know. So the free abilities of an agent in multi-agent systems is, first is, by the way, in no particular order, is event processing, which enables it to update its state using the events it receives. So basically receiving percepts and being able to act on those percepts. Representing information is a second ability, which means it has an internal representation of what it knows or what it needs to know about the environment. And decision making, which means it can take decisions based on what it knows and can take actions based on those decisions. And why is this important? Well, that's basically how Marble is set up. You have 3 different types of files. You have the prolog file, which represents the knowledge of the agent. So that was the representing information. That's what the prolog file does. You have the mass2g file, which is responsible for launch the agent, connecting to the environment, and opening percept channels. So that one is responsible for allowing the agent to react to the environment and receive percepts. And then you have the mod2g file, which is responsible for decision making and taking actions. Of those types of files, you will most likely encounter 4 on the exam. You have 1 prolog file for all the rules and knowledge. You have 1 mass2g file. In the context of the exam, we will only really use it to receive percepts. And you have the init mod2g file, which is responsible for creating the initial state of the agent. And you have the decisions mod2g file, which is the agent will use for the rest of the running time.
Don't you also have like updates, like an update file?
That's the mass2g file. That one's responsible for making percepts. Or is that not what you meant?
No, so you can have like, nah, just don't want to interrupt. It's fine.
All right. These are the files it uses in Marble, as far as I can tell, anyway, or at least on the exam. Maybe when actually having a programming assignment, they'll use more files, but these are the important ones for the exam. You can also have multiple mod2g files if you feel like separating them, but at least I think that was possible in Go, whatever. So the prolog file. We already went over this briefly last time. We'll do it again. It can do 3 things. It can create dynamic predicates, which are basically predicates that can be removed or added from the knowledge base while the agent is running. You define them by giving the name as well as the amount of arguments it takes. You have the normal facts and constants. So if you here you would define information that you already know about the environment before you even start the bot, and that will not be removed or added during the running of the bot. And then you have rules. So rules are when you need to define more complicated knowledge. That's what rules are for. and you can therefore see them as utility functions. Based on that, if there are no further questions, we'll arrive at our first example task. We have 4 things we want to define in the Prolog file. We have the obstacle predicates. Obstacles in this environment are like the chair and the couch or whatever, and they can move around, and they have an X and a Y coordinate as arguments. We have the position of the bot, which also has an X and a Y coordinate. We have the rooms of the house. We don't know the layout of the house in advance, and we define a room by the coordinates of the door, so X and Y for the door, as well as whether they are dirty or not. Finding a room by its door is not the most efficient thing, but for the sake of simplicity, that's how we will do it. The 4th thing is a predicate for the charging station, which we will always have at the coordinates of 0 and Y also 0, because this bot will be using its station as the middle point of its layout of the house. So task for you guys is write a definition for all these predicates that we want to define. How would you do that in the Prolog file? If I'm going too fast and people are not sure what to do, please let me know. Any takers?
Does the obstacle change per room? Is this just one room within?
This is in the entire house, so
Okay.
there are multiple obstacles and they can be moved as well.
Well, I would first put like obstacle predicate in the dynamic part.
All right.
So,
I'll
and
just
then
draw it on screen. So you have dynamic.
yeah, and then so obstacle that will probably have 2 inputs, or how you want to call it. So it would be /2.
Is that the correct slash?
No, other slash you need.
Yeah, I always get them mixed up.
No, I know. And then yeah, exactly. Well, the position of the bot, and these are the obstacle predicate and the position of the bot. They're already like made predicates, or they don't exist yet.
They don't exist yet. That's why we have to define them in the Prolog file.
Okay. Obstacle predicate. Then I don't know actually if the obstacle predicate position of the room charging. I don't think you need to make them the obstacle predicate, because if it's going to be like in the head of the rule for in predicate, then you don't have to make like a dynamic part out of it, only if it's in the body. So
right. So the way the Prolog file works is things that we want to be able to put into the knowledge base should always be defined.
Yeah.
And we will not make a rule for obstacle, because obstacle is just something we receive as information from the environment.
Oh, okay, I didn't know that yet. Okay.
So you do in fact.
Then you can leave it like this. Yeah, then you can leave it like this. And they need to. I guess the position of the bot is also given then based on the coordinates. So you have to also make position bot, because we want to put them in the master.g file in the end. Rooms in the house can change per house and defined by the coordinates of the door. Yeah, I think this one needs to be made. Oh, sorry.
The predicate for the charging station can be a normal fact.
Exactly. So I'll just call it station with 0.0 because we already know it. We always know it's going to be 0. And lastly, of course, the room can differ per house per session, right? So it needs to be dynamic. We don't know it in advance. No rules yet. Yeah, so this would be the answer. Questions? All right, let's move on.
So can I,
Yeah.
the dynamic part, this is always defined in Prolog files. You always have a dynamic section that you show your predicates.
Yeah, so any percept you want to receive should be in there. Anything you want to be able to put in and out of memory. So a question in the chat, why is it room 3 instead of room 2? Or I imagine. So the room has 3 arguments, the coordinates, so an x and a y coordinate, as well as whether it's dirty or not. So those are 3 arguments, and that's where you need to put a /3. Is that clear? Does that answer your question? All right, let's continue. Next file, the mass2g file. So we will only focus on the percept part of it because the rest of the file you will not have to do in the exam. So there's 3 kinds of percepts. Indeed, there is an on-start percept that we added now. So we'll start with the on-start percept. So these would be the rooms of the house. So things that are not known before the start of the bot, and when the bot starts for the first time, are sent to it and then not sent again. So for this, we use the keyword add. They have the send on change percepts, and these are percepts on only sent when that thing is changed. And for that, we use the keyword update. And the send always percept, we receive them using replace, and these are always sent. So whenever the environment decides to send a percept, any send always percepts are always included whenever the environment decides to update the agent. Now, when the environment decides to update the agent, depends on the environment. So that will be given if you are ever asked a question about. And in fact, whether it's on change or send always is usually a design decision. So you can expect to, what's it called? You can expect the question to just tell you which one of the two it is. And the way you actually define a channel by which to receive a predicate or a percept is you use the appropriate keyword, the name of the percept, followed by the slash and the number of argument it takes, and of course the dot to end the line. Not the hardest syntax. So quick task. There's 2 percepts. One that's sent on start percept for the layout of the house, so that will send you the rooms, and one sent on change percept for the obstacles. So how would you write them? And do please write the entire line that you would have to write to make it work, not just the keyword. All right, looks good. You guys are very quick. Add room 3 and update obstacles 2. Yep. Everyone else also understand how it works? Any questions? So these predicates that you would want to add to the precepts. So I mean, these precepts that you want to add to the master.g file should always also be defined as dynamic in the Prolog file. So on the exam, whenever they ask you to write a precept, always check if the precept is already defined in the Prolog file, because if it's not, you also have to add it. Otherwise, it just doesn't work. So rules. We're gonna go through the theory quite fast, but we'll have plenty of exercise later. So the mod2g files contain mostly just rules, and these are the main things that the bots use to do actions. They consist of two parts: the condition and the action. So you have two types: if and then, if you want to do only a single action for a single precept, or well, single condition, and a for all do if we have multiple precepts or multiple conditions, not multiple conditions, but multiple precepts or multiple facts that we want to go through in a loop. I see a question here: will we go through the exam questions of the mock exam? Yes, we will attempt to do all of it, because the practice exam is very representative of the actual exam. So if condition, then action. For all conditions, do an action for each one of them. There's also built-in actions that are important to know: the insert and the delete. There are not many built-in functions in Marble, but these two you should definitely know. Insert basically takes knowledge and puts it in the knowledge base, and delete deletes something from the knowledge base. Question: do you know if there's only one good answer good on the exam? Are there multiple answers good if it's correct in Marble? Given the type of questions that they are asking, they are very simple questions, and they are very precise, like specific questions. So if it works, if your solution is different from what they want and it's correct Marble, then I'm guessing they will grade it as correct, but you will not find such a specific situation very easily, because they are very specific in what they ask. But we will see that in a bit. Right, it's basically just look at an example. So this is the example from last time, but down with the syntax. So this is the way you would always write such a rule. If first you begin with an if or a for all, then the conditions are separated by commas. So if you want to have multiple conditions, you should separate them by commas. Then comes the action part, which starts with either then or do, depending on if you're using if or for all. And the actions, also important, the actions are separated by a plus sign instead of a comma, if you want to do multiple actions, and of course end with a dot. So an example, by the way, this example does not have to do with the vacuum cleaner example. This is just a random example to show the syntax. So you have the condition, another condition, then, and then there's two actions. Note also that delete comes before insert, because if you insert before you delete knowledge in the knowledge base, then it's possible that you immediately delete what you just added to the knowledge base, and a plus to separate them. Now, just a tip: general tip for writing such a rule. In the condition, you will often find 3 categories of things that you're trying to achieve in the condition. So first, if you encounter an atom in the condition, for example here, it usually means that you're trying to filter out when it's supposed to happen. So this condition here is trying to make sure that this action only happens in specific situations. When you see a variable, for example, x, it usually means that you need certain information for your action. And if you need certain information from your knowledge base, you need to instantiate a variable in the condition with it. So a condition is used to both figure out when to do an action, and is also used to collect the information for the action. Last thing you might encounter is an underscore. This is the anonymous variable. When the anonymous variable is in the condition, it's usually indicates that that particular argument doesn't matter, and that's why you just leave it empty. And for this, a variable would also work, but cleaner code would use the anonymous variable.
So there's no syntax for or, you just do a second conditional statement.
What do you mean all?
Like the common is like and, if state and not alive. There's no or.
Oh no, you could use an or.
Like a semicolon. Okay.
Yeah, you could use an or.
Okay.
Could you repeat the not alive part? Right. So usually an if statement is just to make sure that an action only happens where you want it to happen. When you encounter an atom, like alive in this case, alive is the atom here. If you encounter an atom, that usually means the writer of the code was trying to only let the action run when it wants to run, when the writer wants it to run. I lack better wording for this. I should have. I'm struggling to find the correct word here, but yeah, this is really just set a condition when the rules should run. While if you use a variable, because the variable is empty, it will often not filter out when the action should run, and it is instead used to retrieve information for the action. Is that any better? So if the vacuum agent is not alive, it won't run. Well, let me put it this way. So this atom is a predicate with no arguments, right? So if this, it's really bad handwriting. So if this is present in our knowledge base, then this will not run. But if it's not present in our knowledge base, then this action will run. And this is a pretty bad example, because this one is made to make the syntax clear, not to make the workings of it clear. Let's look at the next example. That will make it a lot better. Right. So the task is define a rule that checks if there exists a dirty room, and if so, performs the clean action, which takes no arguments. So this one is already quite challenging, but give it your best guess. And remember, we already defined the room predicates. It consists of an x, a Y, and dirty or not dirty. Dirty or clean. All right, I already see two correct answers in the chat. Should I wait a bit or for other people to try to get their own answer, or should I just continue? I think I'll just continue and explain the answer. If not room, then clean room. All right. I see where you're coming from. So I'll try to explain the answer, right? So we have a, well, let's go to the previous slide first. So we have a room predicate. It has an X and a Y, and whether it's dirty or not. Imagine if we had a knowledge base, and it contained one room with a 4 and a 2, and it's dirty. And we have another room where it's 7 and 7, and it is clean. I hope you guys can read this. So what should we query to return if there is a dirty room? I think, Zoe, would you like to have another try? What would you need to query here to receive back this answer? Or to check if such a room exists that is dirty? Yes, exactly. So you have these two variables, but you don't care about what these are. You only care if it's dirty. So you could use variables as long as they're capital letters. Small letters are atoms, which do not work. But cleaner would be to use the anonymous variable because it means doesn't matter, and check if the last one is dirty. So that's our condition. If there exists a room that applies with these conditions. So if you go to the answer, because we are using an atom here, that indicates that we were probably trying to make a condition. If it was a variable, that means we needed this information for our action, and we're trying to instantiate this variable. Or the variable didn't matter, and it would have been nicer to use the anonymous variable, but that's okay as well. And then clean. So clean is an action that is possible in this specific environment. We just made it up because the environment is made up. Moving on, unless there are any questions. Roux evaluation order. This is a bit that also probably did not come by in the lectures, or only came by very briefly, but it is somewhat important for the exam. So in the mod2g files, there are, of course, a bunch of rules. And sometimes we want to run all of them. sometimes we only want to run the first one. And that's why rule evaluation order exists. Now, if there are multiple rules for which the condition applies, so for which the condition is true, there are different rules for how many and which ones we should actually do the action for. So linear, for example, if the, by the way, it's a setting that can be changed per file, right? So if a file has as rule evaluation order the option linear, then it will check these if statements or the conditions one by one. And the first one for which the condition is true, do that action. And then stop checking the rest of the rules. We just exit the file immediately. For linear all, that's a different setting. It would check all of the conditions in linear order from top to bottom again. But when it finds a condition that is true, it will execute the action, but then continue until the end of the file. So it will execute all rules for which the condition is true. Then we have random. And we have three more, but we're not going to talk a whole lot about the other three because the chance that they will end up on the exam is not very high. But for example, random evaluates them in random order. So first the third one, then the first one, then the second one, stuff like that. And then just executes the first one that it finds to be true, for which the condition to be true. I see a question here. So linear stops after the first execution. Yes, exactly. Then random all does all actions or rules for which the condition is true, but in random order. And then linear random is really vague. It evaluates all the queries in linear order. And the first query that succeeds, if it has multiple options, choose a random one. So that is quite vague, but I honestly do not want to spend too much time on it because the chance of it actually being on the exam is really small. Questions about, well, mainly the first two because the others are. Can you explain what the benefit is of changing the settings, or is it changed on what goal of the program is? Yeah, so it is a design choice, but we will see examples of it in a bit that will make it more clear. All right, next, we've done rules and we've done rule evaluation order. So now we can finally move on to the mod2g files themselves. On the exam, you will find two of them. The first one is the init, which initializes our agent. It is run only once when the agent is created. And the rule evaluation is linear all by default. So you can change it, but if you do not change it, it will be linear all. This means whatever's in there, whatever rules are in there, it would evaluate them all and run all rules that are for which the condition is true. And this is the reason that they use linear all by default here is because usually you just have a list of rules that all have if true, because you want all the rules to happen. Because you usually have multiple variables or knowledge bits that you want to put into your knowledge base at the start, and you only get to use this file once. You want all of them to actually execute. Next one, does in linear all execute everything in the same time? No, so linear all will evaluate if it's true, then execute, then it will evaluate the next. So it does execute it in linear order. In general, computers do nothing at the same time, unless you go into multi-threading, but that's not what we're going to do here. So yeah, only one at a time in linear order, but it won't stop after the first execution. So object.mod2g, I call it object, but it's going to be, this is the main decisions file that the bot will use for the rest of the running time after it was started up. So yeah, it's the main code. Here it will do most of its decisions during the lifetime. Rule evaluation order is linear by default. So as soon it will stop after the first execution. So the order in which you create the rules matters. Now, what is the benefit of this? The benefit is that you don't have to check the same conditions for different rules. And we will see an example of that soon. But depending on how you design your program, you might want to change the evaluation order. But yeah, the benefits of changing it are vague, because this is of course not a very common used language. So this file also runs every time a preset is received. You will not usually find an if true, because if there is an if true at the beginning of the file, it will never run the rest of the file. And actions do not always have to do with the knowledge base. Sometimes they also are just actions onto the environment, just like the clean we saw just a moment ago. Questions about these two files? All right. A couple of notes that I didn't know where else to put. So these two files cannot be changed in a different setting. What do you mean by that? Like the one of linear, all linearly cannot be changed in linear. No, you can change the rule evaluation order. It's just a setting that you can change per file. But by default, so if you do not change them, they will have linear all for the init and linear for the decisions file. But these are the defaults. You can always change them. All right. So notes, just a couple of things I wanted to remark. So when defining predicates and precepts, never forget the amount of arguments. And when a predicate has no arguments, you will not see the parentheses at the end. And you should not make parentheses at the end.
Is this the right way that the slashes go?
Yeah, I always forget, but I think it is. Yeah.
It's the other. I think I can check it actually.
Yeah, let's check it if we should. Ah, no, there are.
That's the other way. Yeah.
Stupid. I should probably change that as well, right? Luckily, when you're on the exam, you usually have an example of, you can just check somewhere where it's already written if what the orientation is. But yeah, it's really annoying. Right, I suggest we take a quick break of 10 minutes and then reconvene at, what's it going to be? 3 o'clock, so that we can start on a practice exam. Does that sound good?
So that's all the theory for Marble. That's it.
As far as this exam is concerned, that's all there is to it.
Okay.
And it would just be mostly practice. All right, see you guys at 15 then.
Can I ask as well that you email me the slides? I don't have WhatsApp.
Okay.
Sorry, I know it's annoying. I'm not a WhatsApp fan.
That's all right, but you'll have to send me your
Okay.
Yeah.
email, or you can also ask the person from.
I got actually one question about Marble. So
Yes.
also like during the like making the assignment for Marble, one thing that wasn't entirely clear to me was so if you make like a predicate, right? And sometimes you don't have to throw them into the must2g file if you like insert it with the init, but sometimes you do. And like the whole concept of doing the update, add, or replace percept in there is that the bot the agent sees what's happening in the environment, right? He knows what's happening. You insert it into the knowledge base, correct?
Yeah.
Yeah. So if you don't put it there, the agent won't see it, even if you insert it. Or can it see it if you insert it anyway? So, and then actually, if you insert something, it goes into the knowledge base and it sees it, I think.
So
Even
the
if you
way
don't,
the difference
yeah,
between insert and percept is that when it percepts something, it will
Yeah.
the environment will directly put that knowledge into the knowledge base.
Okay,
The agent only knows what's in the knowledge base.
okay,
And when you insert it, that's when the agent itself calculates something, for example, and then puts that into its own knowledge base for it later to use.
okay. And the percepts is what you see from the environment.
Yeah.
Okay, and insert it into the knowledge base. Okay. Okay, I think I get it. Yeah, because that's kind of sometimes it's like that's kind of tricky in some way, at least in my head, for some reason. I find that sometimes because how do you say, I lose my train of thought almost from where it's coming and where it's going. Sometimes I find that kind of
Yeah, no,
convoluting.
it's a bit of an unintuitive language,
Yeah,
if you can even call it a language. But basically, the environment gives you percepts and gives
Yeah.
it that percepts have direct access to the knowledge base, and it will be directly put into the knowledge base. While what's it called? While insert and delete is what the agent does on its own knowledge base.
yeah,
And this is actually different from last year with Go, where everything would go for the agent, and
okay,
the environment will not have direct access. But that they changed it now to simplify it.
yeah. And my question about, but I think you already answered it. But how to like write things in like multiple answers, because you can like write insert and delete on very weird ways, because you can like delete something if you insert something and then say not, you delete it. It's really weird. So
Yeah. So
that was my question. That's yeah.
Yeah, because they're not functions; they're actually rules.
Yeah.
Right? So what the insert and delete do, they don't look for something and then delete it. They basically just tell the knowledge base, hello knowledge base, please comply with this state that I want you to be in.
Yeah.
So if you say insert alive, what you're saying is knowledge base, I want you to comply with alive has to be in there.
Yeah.
And when you say insert not alive, you say knowledge base, please, I want you to comply with
Yeah.
not having this.
Yeah,
And then
exactly.
with delete, you're saying knowledge base, I want you to comply with not what I'm about to say, right?
Yeah, exactly. Yeah, it's yeah. Okay, great. That's
So my advice is don't use not.
no, not gonna do it. But I just wanted to be sure because they are not, because we have to in essence you have to write code on paper without because and that's so I hope they just be a bit lenient that if it's like correct but you that for instance you fuck up, oh, sorry, you mistake, you don't do the order correctly, so something comes before something, I hope they don't like give you 0 points or something like that. They just maybe deduct like 0, like 1 from the total points you can get for that question.
Yeah, they do deduct points from minor mistakes. That's not the entire amount of points, but yeah, they give instructions how to grade in the practice exam, so you'll see more details about that.
Yeah. So in your experience, were they lenient or very strict?
I'll be very honest, I don't remember looking at my exam after making it.
Fair enough. If
Yeah.
you pass it, who does, right? Yeah.
Especially since last year the course was given very badly. So the sentiment was, I passed, this was a train wreck, I'm never gonna look at it again.
Was it that bad?
Yeah.
Okay. Wow.
But not as bad as the project multi systems.
Yeah, but that's a hell. Yeah.
Yeah, but don't worry too much because Marble is meant to make it better than last time. So
well, Marbles, it's like okay, to be honest. It's sometimes a bit convoluting, but it's in essence fine. Like the assignment I made, like with the bots and checking the rooms, that was like really doable. I mean, if you, I got stuck on one thing that cost me 3 days, but the whole thing I could have wrote in like less than a day, to be honest.
yeah, Go was not fine.
yeah, that's what I thought. Okay, but I'm gonna have a small break, so thank you.
Yeah. That was a very short break, but we should probably continue because the practice exam does take a while. Everyone about back? Did I just? Oh. Everyone back? Is everyone there? Yes, all right. Time to continue then. So the setup for the marble bits of this exam is going to be as follows. You'll have a big picture like this with 4 small files, and you're going to have a bunch of small assignments to complete this file with. And they progressively get harder. And in my experience with the previous group is that if you did not have a lot of experience programming with Marble during the period with the assignments, then this will be very challenging. So if you didn't program in Marble at all during this course, it will be very unrealistic to be able to do the difficult exercises for the exam. However, you will still be able to do a lot of them because there are quite a lot of them that are doable. So first, the assignment, or the intro, I guess. So the assignment is about a toy security robot that is deployed in a parking garage. So we have 30 floors, 3 floors and 30 parking zones. The robot is able to recharge on floor 1. Are the practice exams for mass representative for the exam? Yes, they are, which is very good for us. The robot is always able to perform the scan floor destination, and it's weird that it's called scan floor, but what it does, it moves to whatever floor you indicated in this argument. All right, let us analyze these files first. Let's start at the prolog file because that's the easiest. We have the dynamic parts, which defines 3 predicates. You have the alarm that has no arguments, and then the add, and then the save, which both have 1 argument. There are 30 zones, and each floor gets its own fact. We also have recharge, which is a rule without a body. So assume we'll have to write that ourselves. Then there is the mass2g file. Now, in reality, you do not need to look at this on the exam. You do not need to look at this during the exam. You have this define block, and this is where you will have to open the channels for percepts. You will be doing that here. That's why they put the dots there, and you can ignore everything else. Only need to focus on this. Then you have the security init. Again, ignore this, realistically. And then here you can write your rules. Then you have the security.mod2g. This one is the most difficult, and you will be doing a lot in here. So we have, again, ignore this. We have a bunch of comments in here and a bunch of rules that are already written. So we have if floor, not safe X, then sound alarm, if alarm, then silence alarm, and if something, which we are going to have to fill in at some point, then go to this floor. Question for you guys, because I find this one quite interesting. We have a X right here. It's an empty variable. We are checking for an empty variable. Now, I find this this condition quite interesting, because can someone tell me what they are trying to prevent from happening in this condition? There is a problem that could occur, but they managed to prevent it from occurring. What they prevent from occurring? Anyone, any ideas? They prevent the alarm from sounding. It should only sound if a floor is not safe. Yeah, that's why they have that condition there. However, what I meant is that they have this not here. It has a sound in the same floor. Not what I meant. So they have this not here, and the reason why they first ask for the floor is to prevent floundering. I don't know if you guys remember floundering from last time, but if they put the not first, it will cause problems with how the condition will run. So what it does is it says for every floor that exists, that's why it's empty. If it is not safe, if there does not exist a safe with the same number, then sound alarm. Could you go very fast through floundering again? That's what I'm doing right now. If you reverse these and first ask if there is a not safe, what it will do is it will ask, let me just write it down here to make it a bit clearer. So what this does is the not reverses the subgoal. So what the safe does, the safe subgoal says, can you find any predicates with the name safe? So if there is any x for which this holds, then true. And not true equals false. But we don't want this to happen because this means that if there is a single floor that's safe, this will always be false. But we want the alarm to sound if there is one floor that's not safe, not if all floors are not safe. So that's why we instantiate the x before calling the not to prevent floundering. And floundering is when this happens unintentionally, the negation by failure. I hope that's clear enough. If you want a complete refresher for floundering, you should probably check on the slides from last time because we do not really have time to go through that right now. We should really move on. Quickly, any questions about anything else? I'll just continue and I'll see if there are any questions about it. So previous group told me that it's really useful to have this snippet on every slide, so I quickly changed that. So first question, and these questions are difficult to understand because they always want you to do something very specifically, and that's why you won't often find that you have a different answer that's still correct because they ask very specific questions. So I'll analyze the question for you guys, and at some point I'll try to let you guys analyze it.
Sorry, before you start, this these files, this is what we're given by the exam question before.
Yeah, it's a picture on the exam.
Okay.
Right, so the security bot is initially at floor 1. Keyword initially. Add an action rule to the agent program in the right place to make sure that the query at 1 succeeds. Also add a rule to make sure that the queries of the form safex succeed for all 3 floors. Indicate for both rules where they should be added. So we want an action rule. Action rule means mod 2G. Initially means only at the start. We want to make sure that the query adds 1 succeeds. Remember, queries are questions to the knowledge base. So what they're saying is adds 1 should return true. So what should we do and where to make sure that this happens?
In the security init file,
Yeah.
if true, then floor 1.
Then floor 1. So what does floor 1 do?
Oh.
It's very unintuitive, I know. I have a feeling that Berend is also wants to do an attempt.
Oh no! Oh well, nee.
All right. Anyone else in the chat wants to do another attempt? Wants to help Orlando out?
Is it then just at 1?
No,
You
because
initialize, no.
that's not how you add information to the knowledge base.
Okay.
You should insert it at 1 in the PL. All right. So let me go through the answer so far. Yes, we should go to the init because it is initially. All right, that part was true. If true was also correct because we want it to happen no matter what. Now, why not in the security in the prolog file is because we only want it to happen at the start, but it's not a constant, because at some point we're not going to be at position 1 at floor 1 anymore. We're going to move somewhere else, and at that point it's no longer constant. Now Berend says you should insert it, and that completes the answer. We cannot say at 1 because Marble will say, what does that mean? Why is that after the at? After the then? Instead, if we want to put anything in the knowledge base, we should always say inserts. And then we can say at 1. And don't forget the dot. Why not add an underscore? What do you mean? Oh, why not add? Add is how you make a percept, but this is not a percept. What does insert do for it to be correct? Insert means put this predicate into the knowledge base. That's what the function insert does. And delete takes it out of the knowledge base. Any more questions?
Yeah, why are they not percepts?
Because the question says they're not percepts.
Yeah, okay.
It just says that's where it starts, and this is something the bot knows, not something that the environment tells us. Any other questions? So can someone type for me the full rule for these, for the safe predicates as well? Again, add a rule to make sure that the queries of the form safe succeed for all 3 floors. No one? Should I just continue to the answer? Oh, there you go. Good timing. So if true, then insert safe with all 3 floors. Yeah, I'm assuming you were just too lazy to write out 3 times, right? And the other one is save. Yeah, makes sense. A rule save x for floor 1, floor 2, or floor 3. So that's a rule. Yeah, you associate it with a rule that you would put in a product file. If true, then insert save x. Right. Let me go through these answers and explain all of them. So first of all, the first one is correct. So it's the same as this one, except instead of inserting at 1, you're inserting save 1. You cannot insert save x because it will say x is not instantiated, so it will not know what to put in. You can instantiate it by asking if floor x, then insert save x, because then you instantiated x with the number from the floor. But then you should do for all because there are multiple floors. Do you get what I mean by that? Yes, and the reason why you shouldn't make it a rule like save x colon dash floor 1, floor 2, floor 3 is because that's a rule that you would put in here, but that's not what these rules are for. So they really want you to just put information into the knowledge base. But it's very good that you guys are I'm very happy with these answers. These are very good answers.
So the answer is for all floor x, then insert safe x.
There's 2 ways to do it.
Oh, okay.
So you can do if true, then insert save 1, save 2, save 3. You can also do a for all rule, instantiate it with floor x, and then insert save x. So action rule is in Moto-G file and rule is in yeah.
Can you just write out what the for rule looks like?
Yeah,
Just
sure. And the question in the chat, an action rule is indeed something you would write in a Moto-G file. I'm not entirely sure if they will be consistent with the way they word it, because they're not always consistent. So just remember that Moto-G files are always those action rules, and they said initially, and it is something that can change. So it should definitely be in the init. I hope that helps. Now let me write out the for all. So the way you would make it is because you wanted to execute multiple times, but for different instantiations, you would say for all floor x do. So the prolog file gets new files. The prolog file does not get it. The knowledge base gets it. The prolog file just initializes the knowledge base. Does that make sense? All right. So for all floor x, and what the for all does is it executes this rule for every instantiation it can find for x, which is 1, 2, 3. Do insert x. Oh, the dot, of course.
But if the prolog file initializes the knowledge base, then shouldn't you also be able to just put it in the PL file? Now, maybe not because they ask you to do it, but in essence, could you just put it in there?
No, because the facts in the prolog files are constants, and
Okay.
these are not
Yeah.
constant because save and add
One
can
time.
change.
Yeah, exactly.
Yeah.
Thanks.
why not insert, oh yeah, you're right, I made a mistake here. Sorry. Insert safe X. Sorry about that. You could be right. Any more questions? All right, on to the next. I have two on one slide because these two questions are almost copies of each other. Assume that battery 1 is a send on change percept, and like I said, they usually just tell you what kind of percept it is. Informing the agent about its current battery level, which is also sent when the agent is just launched. This is the interesting thing. It's also sent when the agent is just launched. So it is sent on change, but we're not using add. But that's just how this environment, how they decided that this environment works, is that this environment will also send it when first making it. Add a channel for handling this percept with the appropriate handler to the code and indicate where you would add this. Also, what else needs to be added to the program to make it work without problems? So they're actually hinting you to not forget something. So either send your answer in the chat, or if you are getting stuck, you can ask a question. I was really confused because she typed delivery bot and I was like, what delivery bot? Oh, right, because they made a mistake in their own exam. And they called the first file delivery bot.mathsdg. There are a couple of mistakes in this exam, actually. But these are mostly just typing mistakes and inconsistencies. First, we update the battery, and we use update because it's sent on change. All right. Line 7. There is also no exit clause in the security mode to achieve. Yeah. But that's none of our business anyway. Luckily. This exam has the absolute bare minimum of what you need for like setting up the environment and stuff. That's not the focus of this exam. However, we're still forgetting something because we just added the percept updates, but will this work without a problem? Or are we missing something? Accumulator? Accumulators are for recursion, and we have no recursion here. All right, I think we do kind of need to move on, so I'm going to spoil the answer. If true, then insert battery X. No, because that's the percept's job, so we should not put it into init. However, we just defined battery here, or we open a channel for battery, but it's missing in the dynamic. Like I said while discussing this, in the theory just a moment ago, always check if the percept you're adding is also in the PL file under dynamic. And indeed, the safe percept that is in the next question is already defined. So we don't have to define that one. But for the first question, we have to both define it here, as you guys said, battery and then the /1. But you also have to add here battery /1. And for C is a send safe one is a send always percept. How do we open the channel for that one? Replace, yes, of course. I forgot the update here, but yeah, update and then replace and then save /1. Let's go to the next slide and see the answers. For the first one, add update battery, and in PL file add battery 1, and then in the second one replace safe 1. Questions about this? All right. Next one. The recharge level is set to 5. That is, if the battery level is less than 5, the robot should recharge the battery. The recharge predicate has not been defined yet in security.pl product file. See, yeah, it's this one. It has been defined, it's just missing a body. So do you guys know how to write out the body? It doesn't take any arguments, so you cannot give it any arguments. All right. I'm seeing an answer in the chat, but I'm just gonna wait a little bit longer until so other people also get a chance to finish or think about it. Is anyone who's a bit stuck? Or is this a really easy one? I find it a bit hard to tell. All right. Well, yeah, so the way you do this one is recharge is true if and only if, well, first you need to know what the battery is. And because you cannot give it any arguments, you need to ask if there exists a battery for any kind of X to instantiate X with however much battery we have. In other words, we are trying to retrieve our battery level before we can check if it's too low. And then we ask X smaller than 5. And then we have recharge is true if and only if there exists an X such that we have the battery level and the X is smaller than 5. If so, then recharge is true. Questions about this one? It's not the most complicated one. Don't we have to define battery somewhere? We already did that in the previous task. So we define it under dynamic, and then we receive it as percept. So it's the environment is responsible for updating our battery for us. But yeah, the code isn't actually updated in this file in this picture because I only have the empty picture. And here is the solution. And yeah, you can see that's one point if a minor mistake is made. For example, probably if you reverse the equal sign or something like that.
Because if you would first start with L is minus than 5, or lower than 5, it would not work because L is not instantiated yet, right?
Yeah, and you're trying to
Okay.
evaluate
something that doesn't exist.
Yeah.
Yeah, great.
The smaller than sign is a math operator, which means it does not instantiate. Next one, the security robot agent can always sound the alarm, but needs to keep track of whether the alarm is on or not. Assume this action is instantaneous and the robot sounds the alarm when it performs the action. In other words, no percept is needed. So already a lot of information. First of all, it is instant, so it's not durative, which is to be expected because durative actions are way harder and they will probably not include durative actions in this exam because they're just too hard.
What's a durative action over an instantaneous one?
Well, imagine if the robot needed time to go from its position to the alarm button to activate it.
Okay.
So right now we're assuming it has some kind of wireless thing or something. I can immediately trigger the alarm. While if it was durative, it would need like 3 seconds to.
Understood.
But in that 3 seconds, someone could, I don't know, shoot a rocket out or something. So that it would fail. Right. It's an action, and it can always do this, which it means it's in which file? In other words, no percept is needed. So no percepts included in this entire question, and also not received. There you go. But the agent needs to keep track of whether the agent is sounding the alarm itself. So it needs to tell itself that it's that is sounding the alarm. Modify the program to make sure that the query alarm succeeds when the agent has just performed the sound alarm action. So first look up where this action is and modify it so that this query, again, this query, and it's querying its own what's it called, knowledge base, and this needs to return true when it just performed this action. I have one answer. If sound alarm, then insert alarm in between 5 and 6. All right. However, sound alarm is an action, and specifically an action with the environment. So I'm pretty sure it cannot be a condition because it's not in the knowledge base. Any other ideas? If not alarm, then insert alarm. This would always sound the alarm.
Do we just change line 8 where it says silence alarm? Do we change that?
No, because we're specifically looking at the sound alarm action, not the silence alarm action.
Okay.
Can you do alarm is true? In a way you can, but the alarm, as you can see in this Prolog file, has no arguments. That means that it doesn't have parentheses and it cannot have anything within the parentheses that it doesn't have. So instead, if alarm is in the knowledge base, that's the same as the alarm being true. And if the alarm is not in the knowledge base, then it's not true. So I think that's enough tries for now. Björn made a good point. Need to add something after the sound alarm with a plus operator, right? So they also say modify the program. In this case, they mean modify a line, right? Not that that's always true, but like in this case. So we have line 5 here. Line 5 dictates when we sound the alarm and when we don't sound the alarm. So if floor and if not safe, then sound alarm. So we already have the condition for when to sound the alarm. So if it's not safe, then sound alarm. We also need to tell ourselves that we are sounding the alarm, which means we need to put alarm in our knowledge base. So we add plus insert, because we're putting something in our knowledge base, we need to use insert alarm. And what this does is it means that if it's not safe, sound alarm, which is an interaction with the environment. And then we also need to remember that we sound the alarm. So we insert alarm into our knowledge base so that if directly afterwards we query alarm, it will return true because we just put it in our knowledge base. Questions? See no questions, and we should really move on. And here you can see the answer. But I'm going to move on. As the security bot agent needs to keep track itself of whether an alarm is on or not, the agent should update its database when it silences the alarm to make sure the query alarm does not succeed anymore. So basically the opposite of the previous question. And let's do this one a bit quicker. So what should we do next to make sure that when it silences the alarm, the same query returns false? Yes, and where should we do that? After silence alarm, exactly. Right here, plus delete alarm. Why is that? Okay, so in that place, I mean, oh, right. Because this is the place where we silence the alarm. So we want to, once we silence the alarm, or once we have determined that we want to silence the alarm, we should do two things: silence the alarm and remember that we silenced the alarm. And that's why it's on the same, after the same condition. Does that answer it? All right. Let me check my slides. Where are we at? So now we're getting into the more difficult territory. But first, yeah. This question, the security bot agent should only silence the alarm if all floors are safe. Why do we not need to add something to the query of the action rule in line 8 of the security.g file to check this? So in this, what they're saying is in this action rule, we only ask if the alarm is on, but we don't ask if it's safe yet. So why do we not need that? The answer to the last one, hang on. So while you guys think about this, I'll just quickly show the previous slide. So this was the answer. Insert alarm on, wait, what? No. Delete alarm on line 8. So why do we not need to check for if it's safe on 8? Okay, I see an answer in the chat, but the reasoning is not entirely correct. Will stop automatically since the first action rule is on. Then if it's on, the second rule will apply. It's linear all. It's not linear all. So by default, the init is linear all. And this one is linear. Right, so I'll explain what's happening here. I think everyone already got the chance to think about it. So linear means that it will only do the first action for which the condition is true. Realistically, this means that if it's not safe, it will sound the alarm and then stop. And it will not evaluate the rest of the file. If it reached the point to where it even reads line 8, that means it did not do this. Because if it had sounded the alarm, it would have stopped reading the rest of the file because it's linear rule evaluation order. So we've already checked if it's not safe, and we have determined that it is safe, otherwise we would have never made it to line 8. So we don't need to check it again. We only need to check if the alarm is on because we haven't checked that yet. Now we are starting to run a bit out of time. Here's the answer real quick. So the next two questions are quite difficult. At least I noticed in the previous group that the gap between all the other assignment exercises and these two exercises is quite large. And since Marble is quite challenging, especially for the people who haven't programmed it before, it is possible that this one is a bit too much. And it also seems that we soon have to move on to recursion. But anyway, so the query in the condition of the action rule at line 11 is missing its condition. So here, line 11, it's missing indeed its condition. Add code to make sure that the robot will move as specified in the comment directly above it. So the comments say move from floor 1 to move to 2, and then to 3, and then from 3 back to 1. So every time it moves, go up until you're at the third, then go back down. So what they're basically asking to do here is that You only have to modify this part, right? You only have to modify the condition. And the action says move to the floor. Floor is a variable because it is already it's because it's already a capital letter. So you have to instantiate floor. That's the only way to complete this. It's by instantiating floor with the correct number. And what information do you have? What information do you have at your disposal to do this? Well, you know your at position, and you are allowed to create new Prolog code, which means here. And like I said, this one is really challenging. I see an answer in the chat. Actually, you cannot use the underscore here because you want to actually use the value in the variable in X. And if you do an anonymous variable, you can no longer retrieve the value from it.
I'm guessing we start the conditional statement with at X, comma, to substantiate, or at floor, sorry.
Actually, the way at works is it's just X. There's no floor in it.
Okay, but to substantiate X with floor.
That is a good idea. That's a good way to start. The problem is the rest of it. So somehow we need to reason that if we have a 1, we would like a 2, and if we have a 2, we would like a 3, and if we have a 3, we would like a 1. I see something good coming in the chat. All right, so that's a good way to start. I'm just gonna explain how you could get to the answer, but I'll admit I'm not entirely sure how you could just come up with an answer like this. So basically, you can make a new fact. You could say go to, and as atoms, you could give it 1, 2. What happens is if you say go to X and then floor, is that if you instantiated X with 1, it would check its knowledge base, which contains this as a constant, by the way. And it'll say, well, the 1 matches and the floor is empty. So I'm going to instantiate floor with 2. Right? And then because you instantiated floor with 2, you can correctly run this. And you can do this for all 3 situations. So you can also add go to 2, 3. You can also add go to 3, 1. So next time you run it, and you instantiated X with 3 because you happen to be at floor 3, it will find this one that matches, and it will instantiate your floor with 1. So my handwriting is a bit messy because of slides and stuff. Let me just go to the answer, which is a bit nicer. I call it go to, they call it next floor, same thing. And yeah, you do not need rules. You could do with rules, but it would just be a bit of a roundabout way. But yeah, this one is simple enough that you can just do with only facts. Only facts.
Almost feels a bit like cheating. You can just do it with just facts. In essence.
Well, for sure, it's hard coded.
Yeah, but it doesn't matter.
We're dealing with Prolog. We're not too yeah. Questions about this one? I'm honestly not entirely sure how you would come up with this yourself. But hopefully seeing this increases the chance of it happening. But hopefully at least everyone understands how this one works. All right. Last one, I could use a break. Especially since we're doing regression after this, holy shit. The agent never selects the recharge action, but that is the most important thing to do when recharging is needed. Add a rule in the right place to make sure that the agent will recharge its battery when needed. Make sure to take the preconditions for this action into account in the query of the rule. So basically what they're saying is make it recharge. And remember, most important thing to do when recharging is needed is to recharge. There's nothing more important than that. Not the most ideal security bot, but Any ideas? Small steps. In which file would you add this functionality? Third or fourth line of Mod2G. Yeah, the way they would ask you to do it on the exam is to say like 3.1 to indicate that it's like in here. But yeah, I get what you mean. But yeah, just make sure you always get the line correctly. So just read the little bit of text above the picture. So you don't lose points on bad notation. All right, so you got the place. Next, what's the condition? Needs to be on top since it's the most important one. Yeah, so that part is correct. It is in there because it is the most important one. So it will be the first it checks. And since it's an action in security Mod2G, if at 1, battery 5, then recharge. So one problem is that you're asking if battery is smaller than 5. However, it does not know what battery is.
This I thought we defined though in the recharge.
Actually, we did.
So then we
We
just
define a rule for it.
so surely just calling recharge at every iteration.
Um,
Oh, if we
the 0.0 thing was from my example for the theory. That's not for this practice exam. That was the vacuum charging station that I made up, not the security bot thing. It's kind of hard to make when we're not seeing what we did previously. Yeah, and the same problem is going to be on the exam because you're not actually going to fill in this picture. You're going to fill in text boxes. So I agree, it's going to be a bit tricky. Also, I'm reading the answer for the exam, and the answer for the exam is really stupid. Like, this is actually not prologue.
If true, then recharge.
No, because that would mean it's always going to recharge, even if it doesn't have to.
So you just need to substantiate what X is.
Actually, let me just walk you guys through it,
Okay.
because I feel like my explanation is actually going to be different than reading the answer from the exam. I'll show you why the answer from the exam doesn't make any sense. So we already made a rule that we can't read anymore because, yeah, we're not going to write in this file, which is annoying. But I'm just going to remind you guys what the rule is. This checks if we need to recharge, because this says battery X, and if the battery is smaller than 5, then recharge is true. So recharge is true only if and only if we need to recharge. So we can say if recharge, that's how you spell recharge? Yeah. Not that it matters. If recharge, and it doesn't have, when it reads this, it's like, oh, I heard that before. That's a query in my knowledge base. Hey, it's a rule, so I should check more things, and then it will check it automatically. So it's like a utility function.
Does recharge have to be first?
In the file, yeah, because that's the most important thing to check.
Okay, so always put as first the most important. I mean in the rule. So does recharge have to be the first one? Cannot add, like the Fourier add, be first? Or doesn't it matter?
That doesn't matter because they all have to be true.
Yeah,
and
exactly.
The
Okay.
order in which you evaluate it only matters in case of floundering, which is not something we have to deal with here because we're not using a not. So if recharge, if it's true, then we should recharge, right? So here comes the tricky part. Seeing a question. If we're not filling in this file, and as you just said, we are just filling text boxes, that means they do not see in which place we specifically place the rule, right? That's why they ask you to tell in which line that you're going to add it. I'll show you that bit of the exam in a bit. So if recharge, then scan floor 1, because we have to go to floor 1 to recharge. That's also in like the first bit of the exam. Plus, not comma, because it's an action, plus recharge. I'm just going to call it action recharge, because also not a capital letter, because that's a variable. Action recharge. So if recharge is true, then scan floor, so go to floor 1 plus recharge, the action recharge. And now I'm going to show you the actual answer from the practical exam and show you exactly why it is really stupid. So if recharge, that part makes sense. Oh, sorry, I read it wrong. Okay, no, it was me who's stupid. Sorry. Yeah, I read it wrong. Wow, how did I not notice that? All right, doesn't matter. So if recharge and we're at floor 1, then recharge. They name it the same thing as the rule here, but this is an action, not a rule from the prologue file. And they check if we're at floor 1. But if we're not on floor 1, then it doesn't recharge, which is kind of weird. Because you would assume that if it's not at floor 1, it will immediately go to floor 1 to recharge. But instead, it's going to wait until it happens to be at floor 1. And if it's not at floor 1, and it's just going to prioritize the alarm instead. It's.
So where did it say that it had to be at floor 1? Were I missing?
Yeah, that's all the way at the beginning, and
Okay.
I would not blame you for not catching that.
Okay.
So, right, this is a bit questionable, this part. So I would still do it if recharge, go to floor 1 plus recharge. That's what I would do. This is weird. And let's go all the way to the first bit. So that's why you need to read exams carefully, right? Because it's 3 floors with 30 parking zones. We didn't end up using this at all, which is funny. It's recharged only at floor 1, and it's always able to perform the scan floor function. The action recharge is different than the recharge in the PL file, right? It automatically differentiates them. I don't know, because they did not, with this exam, actually tell you what possible actions there are for this environment. That's why if it were me, I would name them differently. But yeah, this exam is not made perfectly. On the next slide, so we have this is like, again, part of the practical exam. So I was copying this bit first the entire time because to save space. But if you read the bit above it, and do make sure you read it, you have to specify which parts you are changing and in which way you are changing it, because you have to write in text boxes. And that's what you see in their answers. They say in security.moduji add line 4.1 if true, then this. You guys understand that? This has been the same for 3 years, so I really do not expect them to change this. Any more questions? Because if not, we should take a 10-minute break and then
The 4.1 means like at line 4, first new rule. 4.2 means fourth line, second new line. Am I
yeah,
seeing it
so
correctly? Yeah. Okay.
yeah, pretty much. So between 4 and 5, add a line, and then 4.2 means add another line below that line. You know. All right.
Can I
So
just ask a question for in general? I mean, it can be over the break as well, but just where would the actions? How would the agent know what the actions do? Like where a sound alarm, for example, and silence alarm, where are they kind of defined, or is it just
they're programmed in the environment itself.
okay?
So when you actually have an assignment where you have to actually program a real bot, they'll give instructions about which actions are available.
Okay.
In this exam, they do not give you a list of actions that are defined with this environment. You just have to make up a name, I guess.
Understood.
Have I told you guys yet that it's not a very well liked course? Anyway, let's take a break till 15. No, what time is it? 16:15. And then do recursion. I'll see you guys in a bit. Well, I am back. Break is not over yet, but I see a question in the chat. But I'm not sure if that person is still at their computer. So I'll just, all right. So it's wrong because it's not on floor 1. It's nowhere specified they should move to floor 1, right? Yeah, so I mean, they made it, so I can never be sure if it's wrong. I just think it's weird because they say that the most important thing is that it will recharge if it needs to recharge. However, if it's not on floor 1, then it won't recharge and it won't even do an effort to go to floor 1. So I would say if it needs to recharge, just go to floor 1 even if you're already there and then recharge. But they would probably not mark my answer as incorrect, because after all, these are just design choices, right? These are not absolutely correct or absolutely incorrect.
But is there an rule that or predicate that says that you can go to a floor? Isn't that the reason why they just do floor 1?
We have scan floor, which is an action to go to a floor.
Is it? Okay, then maybe I did. Okay, then I say nothing.
I mean, let me just check for sure. The robot is always able to perform a scan for destination for moving from one floor to the next. Yeah, so we would assume that that's that. And we're also assuming that the scan floor also immediately updates the knowledge base about where the bot's at. Because otherwise it doesn't update that anywhere. So you would need to add a delete and an insert there. Know what I mean?
Yeah, I know what you mean, but there are a lot of assumptions need to be made that makes the exam maybe harder than they actually mean to make it.
Or this might be a result of them trying to make it too easy. But
That's let's hope for that.
yeah, and let's hope that they are lenient when you come up with a better solution than their solution, right? All right. Time to make the final stretch. Está correct in English? Recursion. So the previous group, after the Monday session, asked me to give a more comprehensive guide about how to write recursion, how to come up with it. This was quite difficult for me because it's like Python functions. There is no one good way to write it. So instead, I just try to put into words my own approach and practice recursion from that approach. And my experience is not possible to learn recursion from start to finish in 1 day or 2 days even. So if you haven't done recursion for the assignments during this course, then again, you'll have a lot more difficulty, probably. But just to give it the highest chance possible, we're just going to spend the rest of the class practicing recursion. So here's my approach. In hindsight, step 2 always comes before step 1, but depends, I guess. So the first step is to consider the base case first. So when does the rule stop doing recursion, and what should happen when it reaches the base case? And this is, by the way, just Prolog again, no more Marble. We are done with Marble for this class. The second one is to solve the problem on paper. So don't use Prolog, don't use your computer, just write it down as if you are Prolog. So just worked out the problem on paper, basically. So no easy access to data, and only the one element at a time. You can only access the head and not the tail. I mean, you can only access the first element, not the last element. And then try to replicate your actions in Prolog. So I'll give you an example of this. So first example is find the kth element of a list. And the rule definition is you have the k, that's the rule. You input a list, the number that you want, and the element, the last variable is where your result will be. So example output is if you input this list and then the free, E will be instantiated to free, right? Because it's a third element. So I have the approach written out on the slides. However, I think it's better if I just what's it called? Instead, do it live. So we are trying to make this rule. The L, the K, and the E for elements. I'm not always very consistent with which letters I use, but that's okay. So imagine let's do the solving on paper first, because that's what all I always do, just in my mind, is I think, okay, imagine we have an input of a list of 5 numbers, and we want the third element, right? We have the K, and the K is going to tell us which number of elements we need. So in this case, we need the third. So we can't directly access the third because it's a Prolog, and we can't do that. We can only access the head. So we're going to have to recursively go and take off the head. So the first time we do it, we end up with this list. So now what we see is that the element that we want has moved to the second place instead of the third place. The second place, not the second index. I'm not using the thing where index starts at 0. So now the K should be 2 because we want the second element now. We recursively go for it again and remove the head. And now it's in the first position. And this is, if I were Prolog, the point at which I would like to stop doing going recursively through it, because I have the free in the head, and the head you can directly access. So what have we seen? We should stop doing recursion once we have reached that the k is 1. And if we stop recursion, that means it is the base case. So in this case, the base case would be L. Actually, doesn't matter. Doesn't matter? Actually, doesn't matter. Sorry. So let's just do this. Head and tail. This should be 1. That's when we want our base case, as we've seen by just working out the problem. And then the element we return, we still don't know. Now, what do we want to happen when we reach the base case? Well, we want to return the head. E is the variable that we use to return the element that we want. So we say, and E is empty and H is not, which is the head. So we say E equals H to return the head. Right?
Why do you need the tail for that? If
We
it's-
don't. We can just say
Okay.
this, like this.
But and if the tail is empty, is that fine still? Like,
Yeah,
will
it would just
still
say
work?
T is equals the empty list.
Okay.
That does work still. It's a good question. These are all Prolog specifics. And the only way to know all the specifics is by doing a lot of Prolog, which we're not going to be able to do in 1 hour. So now we want to recursively get to the base case. And what did we, sorry, what does E mean here again? E is the variable in which we get our return value. So in Prolog, when you recursively go through a list, usually the last variable is a variable that you leave empty so that you have a place where to get your answer from. I'll show that again when we, what's it called? I'll show that again when I actually run the function. Also, my headphones just said low battery, so that's might be a problem later. So we want to recursively get to at the point where k is 1. And how do we do that? Well, what we did while working it out on paper is we had a head and tail. We had a k, whatever it was. We had an e, which we still don't know, so we leave it empty. And what we were doing, we were doing k new equals, no, not equals, is, because we need to evaluate it, because it's math, e minus 1. And not e, I mean k. K new is k minus 1. Because k is already instantiated with something, doesn't matter what it is, but it's already instantiated with something. And so we need to make a new variable, and we need to use the is because we want to evaluate the right and instantiate the left with it. And that's exactly what the is does. Next, we want to run it again. Does that mean E is H is possible in here? Yeah, actually, if you just do this, that will also work. But it's bad convention, I guess, because is more specific to math. But we'll just to make sure that it works, we'll just leave the is there. So then you recursively do it, and when calling the loop, we only give it the head because we were trying to make the list smaller. We give it the new k because we're trying to reduce the iterator, and we still don't know the e. It will probably tell me that this is a singleton variable, which means that it's a variable that we don't use, which means it can turn it into the anonymous variable. It complains when I don't do that.
Shouldn't be like in the base case, shouldn't like after the double dot minus, shouldn't it just be the KTH again? Because now it just says E is H. It's not
No,
instantiated? No? Oh, okay.
because if you type kth again, then it will try to run it again. But that's because it's the base case. We don't want to run the rule again.
Oh, yeah, of course.
So what this means is kth is true if and only if this instantiation is successful. Right? So before I run it, I should comment these out, otherwise it will error.
This is left recursion, right? Because the recursion's on.
No, the recursion is on the right, so it's tail recursion. Left recursion means it's not the last thing you do.
Yeah.
Keep the questions coming, by the way. It's make sure you don't have no more doubts about how anything works. And then E. So again, we put an empty variable here because the E, the third position, is where we expect to receive our output. Right? And it gives us E equals 3. When is it left-tailed and when is it right? Okay, so left-tailed recursion means that this recursive step is not the last thing you do. And when this recursive step is the last thing you do on this line, then it's tail recursion. So it's left or tail. There's no right and there's no head. Does that answer your question? Can I draw on the screen? Yeah, I can. Wow. Zoom, I guess. So this is the head of the rule. If the recursion is the last thing you do, it's tail. And if it's not the last thing you do, then it's left. So yeah. Yeah, so this equal sign does not matter in this scenario, but the equal sign is better. Any questions about this? Is it clear how we got here? This one I just did
You can also do it in other ways, I guess, right?
In a lot of cases, there are multiple ways to do it, and but this is just my version of this one.
Because it sounds very stupid, but I didn't first see where you got the H from. But of course, it's the head. I didn't look correctly, so that's why I also asked it earlier. But okay, I get it.
All right. Question is, why do I use the anonymous variables? Right. So let me just put the variables back. I was already afraid that might be a bit confusing. So in the base case, we want to return the head, but we don't do anything anymore with the tail. And in the recursive step, we throw away the head and then pass on the tail for further recursion. So in this one, it doesn't matter what this one is, and it doesn't matter what this one is. So when I run it now, it's really annoying. It will give me warnings about singleton variables. And singleton variables are variables that I define and then never use. And this doesn't matter. This doesn't reduce points on your exam, but this is just annoying because it's giving me warnings. So I'm just replacing them by anonymous variables. Does that answer your question?
Hi, sorry. So if I'm getting it right, for the exam, if we don't replace it with a underscore, it doesn't matter, or?
I'm pretty sure they won't subtract points for it.
Okay, so like, why doesn't it work on the program? Is that
It does work. It gives me the output, but it's warning me that I'm defining variables and not using them.
Oh, okay, yeah, thank you.
Yeah, and I just don't feel like looking at it, so I'm like, okay, fine, run. Too many open queries. What are you talking about?
Yeah, if you you have to like delete the history or something, like on the right above.
Oh, Jesus Christ. How do I clear it?
No, like on the right up. on the 3 dots there, if I'm not mistaken, and then stop all unclear. And I think, yeah.
Okay, thanks. I haven't used this online thing before, but I don't have Prolog on this computer and I didn't feel like installing it. All right. Let's quickly move on to the next. Oops. Where's the chat? I also need to close the chat. Let's go back to the slides because we're taking a bit long. So yeah, first what I did is I checked what it should do on paper without actually writing any code. Then I figured out the base case. It's always easy to begin with the base case and then do the recursive step. And then I did the recursive step. Okay. So next one, I will be doing as little reasoning as possible, and I will let you guys do most of the writing for me. Well, I mean, I'll be typing it, but yeah. So the task is find the last element of a list. So we have a rule. It's called last. We have received a list as input, and we want the last element of the list. So let me get out. Oops, out of it again. I hope no one saw that. Last, and the input is a list and a last as outputs. So imagine if I have given an input of 1, 2, 3, 4, and I want a. Actually, that's it. That's the only input. What should it do? What should Prolog do without code? Just what steps should it take to get in a position where it can give back the last one, the last element?
Delete all the elements and then return it when there's a single, which is.
Yeah, so remove the head, right?
Yeah.
Remove the head until there's only one left. So what could be the base case? How do we put this into a base case? How can we check if you only have one element? It's actually multiple ways, but yeah.
A list of.
Right. So we already have an answer in the chat. Anyone else who also wants to try? Maybe try a different, because there's actually multiple ways to do this. And my solution was different, although this solution is better, but yeah. Yep, that's also a good base case. All right, so the base cases can't get much better than this. So yeah, one way to put it is if you say, I want a list of only one element. And then put that element in our output. If you, so what Berend did was also correct, would also work, but it's a bit longer. So R for result or whatever. Then put R equals the L. You instantiate R with L. My version was even longer. I would say head, tail, and then result. And then if the tail equals empty list, R equals H. So these are all, wait, syntax error. So these are all the ways I can think of to make a base case. Does everyone understand how all of them work? I'm gonna assume you guys do. Can I explain the last one? Yes, mine is the most weird one. So if we are looking for a function, a rule called last, and you have a list of any kind, and an R, then check if T is equal to the empty list, which means that if there is, you're checking if there is actually something in the tail. Because if you call, if you have a list with only one element, it will, and you call head and then tail on it, it will say H is 4 and the tail equals empty list. More specifically, imagine if you're trying to take 2 heads, because you can do that. And then you have 4, 2. It will say H1 equals 4, H2 equals 2. But if you only have one element and you're asking for 2 heads, it will not run at all, because you do not have the conditions needed for it to run this rule. Which is also why these approaches work, because you're asking it only for an element with only one element, a list with only one element. And if it has more elements, this one will not run. This is in Prolog. All right. I deleted all of them. I was maybe not. All right. I'll just keep this one because this one's the most elegant. So then the recursive step is, what are we doing every time to make sure we can advance? Well, we're always only taking the head. We're only removing the head. So this will be the recursive step. Let's try it. And it will complain about singleton variables because I'm not actually using the head. Whatever. This one's clear, right? This one's decently easy. Let's quickly move on to one that's much harder, because we don't have a lot of time to take the mean of a list of numbers. I'm sure you guys recognize this one from last time. Last time it didn't go that smoothly. But this time we came prepared. Yes, I did. So the mean of, let's do an easy example. So 4 and 8. And the result should be the M. So imagine we have a list of 4 and 8 as inputs. How do we calculate the mean? Imagine if you were just a person trying to calculate the mean, but you could also only take one list out of the element one at a time. As the base case, I'm just asking for how you would solve it on paper. So imagine you are a person and you're trying to calculate the mean of a list of numbers, but you can only read one number at a time. Add each to a sum and divide by the length, or to 0. All right.
As in add to 0 instead of a variable sum.
Right. So yeah, you would need to get the 4 and then add it to the 8 to get the sum. And every time you add something, you would also add 1 to the length, because you also need to check how long it is. So that you could at the end say divide the sum by the length, because that's how you calculate the mean.
So you keep adding the heads. You don't start at 0.
I do start at 0.
Oh yeah, because you have to add the first head to 0. Okay.
Yeah. But there is a certain technique that is very useful for this kind of calculation. What technique would be very useful to use here if we have to add up stuff?
An accumulator.
Yes, one or more
Two.
than-
2. 1 for length, 1 for sum.
Yeah. Why don't we initialize by mean and then mean sum, length, and result? Oh, that's what I'm sum. I don't know what the R is, but yeah. Usually I do the initialization at the end, but you definitely have a point. We would have to initialize the thing, but I'm gonna leave that for the end for now. Okay, so the base case with S the sum and R the number of times we do the recursion. Yeah, pretty much. So for the base case, we've already established that we want 2 accumulators. So I'm just going to give a slightly different name. We have the list. The list needs to be empty, right? Because we need to go through the entire list before we want to actually calculate it. Then let's assume we've been accumulating the sum of the accumulator of the sum and the accumulator of the length. Let's assume if we keep tracking of that the entire time. By the way, the position of these accumulators doesn't matter. You could just choose any order in variables. And then we would need the mean at some point. I'll get to what you just wrote in the chats in a minute. And then the base case would be the accumulator of the sum divided by the accumulator of the length. And that would be we would want to save that into the mean because that's where we get the output.
Do we, for the base case, do we not want the list to have an element in it?
No, because the base case means we stop recursion.
Can it also make the base case with like 2 values in it and then a double point and then do the M, so that's the value you want be on the same place as like the mean with 4 elements in it, if you know what I mean. So because it
not
gets
really
like
following what you're trying to say.
maybe I type it out. I think that's
Yeah, you should
I think
probably type it out.
somebody similar did some. Okay, I'll type.
I'm really bad at hearing code. I'm already seeing some code for the recursive step. That's really good, but we'll get to that. My question is, did everyone follow me as far as the base case went? Could that be the base case? That's not the base case, that's just initializing. Yeah, no, that's because you don't have anything to fill the accumulators with. I feel like half the people are trying to think about this and solving it, and the other half are waiting for me to finally continue. So I'm gonna try and continue. So this is the base case. I hope everyone understood that. Let me just go over it one more time. So we want to stop recursion as soon as this is empty. We decided to go with the accumulator approach. So we have the accumulators and we assume by the time we reach the base case that they are now filled with numbers. and the mean is still empty. So we instantiate the mean for this sum divided by the length, because that was our approach. Initializing the accumulators is something I always leave last, just for simplicity. So the next step is a recursive step. So every time we reduce, we take the head of the element, we want to add the value to the accumulator of the sum, because we're trying to take the sum of the list, and we add 1 to the length, because every time we add another element, the length increases by 1, right? So mean, head, tail. So this is our list. This is if I had a tail. The accumulator, the other accumulator, and the mean. And what we're doing is we're making a new sum, and defining it as the old sum plus the head. And then the new length is the old length plus 1. Definition for the accumulator. Okay, so the reason we have an accumulator is we need somewhere to store our progress for calculating the sum. So we create an extra variable so that every time we do a recursive call, we have a place to store our new sum. So that once we reach the end of the list, the accumulator contains the entire sum of the entire list, and we can then do the calculation. That's the idea here. And if it's difficult, I get that. It's kind of to be expected. And like I said, if you haven't done any recursion during this period, then it's going to be really hard to follow this, because this is not something you can learn in 2 days. Well, I mean, you can understand it in 2 days, but you can't. It's really difficult to do it yourself after 2 days. So once we have done the accumulators, we should do the recursive step. We call mean again. We give it a tail only because we're trying to progress in the recursion. We give it the new accumulator, the new sum, and a new accumulator for the length. And we still don't know the mean. Our original function only took 2 arguments. So now what we're going to do is make the initializer, which again is not necessary, but it's easier. It's of convenience. So we have a list and a mean. The list is the input and the mean is the output. And we initialize our accumulators always at 0 and 0 because we're taking the sum. And when you're taking the sum of something, you always start at 0. And passing on the same unknown, the same input and the same unknown output.
You just have to rename the for input function to accumulator mean, no?
So what was that?
So mean LM equals ac mean L00M.
Wait, who else did I hear?
Sorry, that's just because I have people in the room.
Oh, okay.
Now, I don't think it needs to, right? Because mean 2 is something else than mean 4?
Yeah, exactly. So you don't need to
Yeah.
change the name. I did that last time for clarity. And we can do it again. So we can say mean init or something. Just to not confuse yourself between the two, you can make them different names. But when looking for a predicate by the name of mean, it does also check if it has the correct amount of arguments. And for the same reason that when we're checking for the empty list, we also don't need a different name because it will see that it doesn't have an empty list. It has something else in the place. So it will just skip that one. And it will only run this line if it has an empty list in the first position.
I remember we had to put like, there was a reason we had to put the accumulator statement at the end, like the first line. I could be wrong, but
Accumulator statement at the end, what do you mean?
like the first line in this, I remember in the slides it was put at the end of everything, at the bottom line,
I'm not sure what you're talking about.
where you initialize the zeros.
Yeah.
I thought that had to be at the bottom.
No, it can just be at the top. I guess it doesn't really matter where you put it. I just put it at the top because that's clearer, probably. So when we run it, should just work. Or am I wrong? What?
I do think that's because you
You
haven't.
missed a dot.
Missing
Oh.
dot. Yeah, no, it works. Yeah, so that's recursion. Like I said, it's really difficult. I tried to explain it as best as I could think of doing. And the only real way to be able to write this yourself is by practicing. Will there be a lot of recursion in the exam? Actually, no, there will not be. It will be 1 or 2 questions, so around 10 or 15% of the exam. It won't be a lot, but there will be 1 recursion question, and it will probably not be an easy one. They're always not a lot of points, and it's only 1 or 2 questions, but they're pretty hard. So that's why I'm trying to go over it, because I don't want to. I want to have gone over everything, but at the same time, 2 sessions is too little to actually get you to that level. But yeah, any more questions? This is also just about the end of this session. So if you have any more questions about any of the course material in general, now is the time to ask. Some advice on how to prepare for the exam, because I heard that it starts late tomorrow, not early. So you still can study a bit for tomorrow. Is definitely go over the marble exercises of the practice exam again, because there aren't a lot of marble exercises to be found. There's also a programming guide. I have it open here right now. So this programming guide for marble, it is quite long, but you can skip a lot of parts of it. Does it have a index? No, of course it doesn't have an index. Why would it? While this it's long, but it's worth it to read. It really is, to give you a better understanding of how marble specifically works. And if you feel confident enough to try the recursion example, you could at least score some points of it, but you should practice more recursion, because recursion is always difficult. Would you say that this mean recursive example is harder than the ones we will get in the exam? No, this one's easier. This example is easier than what you will probably get on the exam. unless they decide to make it easier than the previous years. Yeah, I know it. Although the example they have in this practice exam is comparable. But yeah, no, they're really difficult. I remember in a previous exam, I think the mean was given, and then you had to use it to calculate the standard deviation, something like that. So yeah, could we get the slides? Yeah, I'll send the slides right after the I close the Zoom. So yeah, practice recursion. Go over the slides again because it's a pretty good summary of all the theoretical stuff we need to know, also like operators as well. If you want to, and I do recommend it, read the programming guide for Marble. You can skip all the Blocks World example stuff, but it's actually like some real documentation in there. Any more questions? You can also send questions in the WhatsApp group today and tomorrow. Yeah, that's about all I have to say. Oh, one more thing. So of course it's Athena, so they ask everyone to fill in this evaluation form. I don't know why step 3 is sit back and relax, because after this you're gonna have to study for multi-agent systems. But yeah, please do fill out the evaluation form. And thank you all for attending this class. And good luck on your exam.
Thank you very much. Cheers.
Thank you very much. Especially the last part on recursion was very helpful. It made a lot of things very clear to me.
Glad
Thanks.
to hear. Yeah, I'll leave the Zoom open for a bit for this QR code, and I'll close it in a bit. So see you guys.
One quick question, if it's possible, because
Yes.
in essence, what you did, because I made all the assignments and I did it in I think a way stupider way. The recursion, it works in the end always, but way complicated. This is way easier. I didn't even knew you could do it like this. Just could say like with the base case, because they usually like in the slides and how they prepare you is they say the base case has to be like it cannot have like a dot, like what it is. It doesn't have a body usually. The base case it only has a head. If you know what I mean.
Yeah, so it's just a fact instead of a rule.
Yeah, exactly. So this is way I never came up with just doing it, because this way it's at least to me it's way easier to do it how you do it.
Yeah, but
thanks for
also if you for example go to wait, I have to let me just pull up the practice exam.
Yeah.
Let me check if it's the correct one. Yeah. So this is the practice exam.
Yeah.
And if you look at it,
Oh, they do it the same way.
they also
Yeah.
do it right here. So it's
Oh, no way.
yeah, no, it is quite common.
Okay, because this, at least to me, it makes like all the blocks fall into place, because it's way more, doing it like this is way more like Python Nick, if you want to call it like that. And in my opinion, it's way easier, I think.
Yeah,
I don't know if people
I
agree.
think the only difference is that sometimes just a rule is enough. Just like when the parts in Marble, when we were trying to do the floors.
Yeah.
Sometimes rules is enough, and sometimes a rule is needed.
Okay, great. Well, thanks for everything. It was a great refresher.
Yeah, glad to hear, and good luck.
Thanks.